So we're going to make today's notes short and sweet. Get it in and we're done. All right, so I want to start us off with this concept of a point. And what is a point in geometry? Right? This is something that's kept plotting over and over. What does that represent? Point on a line. Okay, so some is just the point, right? Think about a point as a singularity. That's the little astrophysics term there. It's a singularity. And what that means is it has no dimensions. There's no depth, there's no width, there's no length to it. It is literally just there. How do we represent points in geometry? When you guys were plotting points on the calculator, what do they look like?
Dots.
They look like dots, okay? And normally when we label a point, we label with a capital letter. So we call that point A, is how you would say that. Point A. The next thing that we want to talk about is we can actually go from a point that has no dimensions. So we want to make a note of that, no dimensions. We're going to move naturally into a line. How many points does it take to make a line?
2.
2. You need to have at least 2 points in order to construct a line. So think about making that line. Here's our line, and then we naturally say that that line is infinite, so we represent that with 2 little arrows at the end. How many dimensions does a line have? How thick is a line?
As thick as your pencil.
Pretty much, right? But theoretically, it has no thickness. It's infinitely thin. Well, what is the single dimension that it actually does have? If it doesn't have width, what does it have? It has length. And the 2 arrows at the end of the line tell us that they go out for infinity. And we have multiple ways that we can label a line. Most of the time what you're going to see in geometry is we're going to label this with the 2 points. Any 2 points on the line can be used to name that line. We would call this line AB. Notice the symbol on top of the AB. Actually, it looks like a line. Okay, so we can say line AB. Another way that we'll often do this is there's at the end of the line a little lowercase cursive letter, usually M or N. We would call that line M. Like I said, a lot about geometry is learning how to interpret what you're seeing. So like I said, we're going to read that as line AB or line M. Can I cut up a line? Can I do that, right? Can you prepare scissors and cut the line? Okay. So when we think about lines, there's actually 3 types of lines. There's a line. What are the other 2? We got constructed those today.
Segment.
Segment's another one. An array. Okay, and all array is think of it like this. I'm literally going to take this line and I'm going to cut off all this extra stuff over here, and so all array looks like is an arrow. So that's array. So in our case, array has a single endpoint. Our array is a single endpoint, and again we represent that with the endpoint first. So going from A to B, so we call that array AB. So it's AB with the arrow over it. 2 arrows means a line, 1 arrow means array. And that's, again, array is just a portion of a line. And then I can cut that line out even further by lopping off the other side of this. And now I've gone from no endpoints, 1 endpoint, and then our last one is a segment. segment has two endpoints. Point A, point B. So we would represent that as segment. All right, any questions on this? How many points are on a line? What do you mean by diminishing? Yeah. All right. How many of you guys have ever actually looked at your television screen? Okay, so when I'm up here this close to the board, way back in the room, we see a single image, right? Well, what am I really looking at? What's an image? What are those images called? Pixels, right? We're used to that. In the digital age, the pixels kind of make sense. When we look at a line, that come up here, the line is really just an infinite number of points that are all squished together. So from a faraway view, it looks like a single line. But if you were to zoom into that line, you would see a series of points, one after another, stacked up. But even when you zoom out, you see it as a single image. So a line is really just an infinite number of points all lined up next to each other. Okay, does that kind of make sense for you guys? So no matter, I can put A and B anywhere I want on that line, because it's just a series of points that are connected. In fact, if I want to zoom in and say that, I got 2 points right here and right here, well, there's a space between them. But if I zoomed in on that space between them, there's even more points in that space. So again, points are infinitely small. And they're just kind of a theoretical thing to look at. All right, the next thing I want to talk about is a little bit of symbolism you guys might see. What does that mean? You know? It means perpendicular. What does it mean to be perpendicular?
The opposite of parallel.
Opposite of parallel? Not really. What's perpendicular? Not a right triangle. Yes, it's a right angle. So it's two lines that intersect at a right angle. So what I want is some way to draw this for me. Who thinks they can draw that? Yep, they're going to intersect at a right angle. Okay, anybody want to try drawing that? Go ahead, Zach.
Supposed to be.
Okay. Right now they're just intersecting. What tells me they're perpendicular? There we go. Yep, got it in the box. Is that the only way that it could have been drawn? Is there another interpretation we could have had? Or is that it? Really? Okay, explain. Yeah, so the line could have gone through AB, so that D could have been down here. And that would have been fine as well. Alright, and then the last one I want to make sure we talk about, I guess there's two more, so that's perpendicular. The two L's next to each other means what? Parallel. What does parallel mean? Parallel, I guess, is I'm probably going to tell you it wrong. Mason.
They never cross paths.
Wrong. But yeah, that's pretty pretty much it. If we're dealing in 2 dimensions, that's a good definition for parallel. 2 lines that never intersect. When we leave the 2-dimensional world, we have all types of weird things that happen. I will prove to you later on that parallel lines will intersect. And then the last symbol of the day, what is that? No, that if it's okay, about equal to is 2 squiggly lines. So what is this? It's a word we're going to use a lot in geometry. Congruent. Okay. All right. There's equals, and then there's congruent. Okay. It's kind of like there's trash bags, and then there's hefty trash bags. Okay. The congruent is like this really super heavy level of equality, where every single aspect is exactly the same, not just the measurement. Every single aspect is the same. So congruence is a technique. All right, that's it. That's all we have to know.